Hi students, this is Mr. Yao. In the last lesson, we have learned to graph from system inequalities. So of course, in this lesson, we're going to go backwards. We're going to write inequalities from graphs. Prior knowledge, linear equations can be written in the form of y equals mx plus b, and we have the slope and the intercept. So of course, we're going to do a lot of that for today. Linear inequality, the only difference is instead of using an equal sign, we're going to have greater than, less than, greater than or equal to, or less than or equal to. Before we get into the actual examples, let's quickly go through a few different graphs and match them with the inequalities. I'm going to ask you to pause here and try it by yourself. Hopefully you have tried it. Just quickly looking through these, you may notice A and B, the inequalities, they both have equal sign. So of course, they're going to have to correspond with either B or D because these are the two that have solid line. Then C and D does not have an equal sign in the inequality, so of course they're going to have to correspond with A and C because these graphs both have a dotted line. So now that we know that, let's see how we can actually tell if it's less than or equal to or greater than or equal to. X minus y is less than or equal to 5. You can use the checking points. Well, you see the distinguishing point could be 0. So we can use 0, 0 to check. And get 0 is less than or equal to 5. That clearly works, which means for A, 0, 0 should actually be in the shaded area. That's corresponding to B, which means for B, inequality has to be corresponding with the graph in D. As for C, we can still do the same thing. That's a 0 that's greater than 5, which is not true. So for C, you can't include 0, 0 in the shaded area. So that's graph C, which automatically that means inequality D is going to correspond with graph A. So that's just kind of some quick going through inequality, matching them with graphs. Now, let's get to the examples to see how we can write the system inequalities from graphs. First, since we're writing system, of course, we are going to have the curly braces so that we can actually write the system inequalities. In order to write them, we are going to need to choose a line and start with the slope and y-intercept. So first, let's deal with this line. The y-intercept is at -3, so it's a -3 on the end. The slope is up 4 over 3, it's going to be a 4/3 x. Now that leads us to the second step. We can't actually write equal because, well, these are supposed to be inequality. For now, we don't know the symbol, so we're just going to put a y and leave a space in the middle so that we can fill in the inequality symbol later. Let's also write it for the other line, this one. The y-intercept is at 2, so it's a +2 on the end. The slope is a down 1 over 3, so it's a -1/3 x. And we also just have a y. Next, we are still going to do what we did in the previous lesson. We are going to use points to test. But we can't just choose randomly a point. In other words, we can't just always use 0, 0. We have to choose a point that is in the shaded area. So step 3, we're going to choose a test point from the shaded area. We're going to plug them into the inequalities. Well, the potential inequalities. Right now, we don't know the inequality symbol. So let's pick a point and plug them in. In the shaded area, we can pick, say, 3, 3. We can always pick numbers to make our calculation a bit easier. You notice the fractions is a 4/3 and a -1/3, which means if x is a 3, it's going to make things a bit easier. So you can choose like 3, 2 or 3, 3, 3, 4, any of them. So let's say we're going to choose 3, 3. The second 3 is going to be for the y, and the first 3 is going to be for the x. So we got a 3 on the left side, and it's a 4/3 times 3 minus 3, which is actually going to be a 1. So we're comparing a 3 and a 1. So our goal is to make this inequality work, which in other words, since 3, 3 is in the shaded area, we have to make these final answers work. So it has to be greater than, which means the symbol is going to be greater than. As for having the equal sign or not, that's purely dependent on the kind of line we're having. If it's a dotted line, we can't have the equal sign. If it's a solid line, we can have the equal sign. It's not decided by the inequality calculation, it's just by what kind of lines we are having. And since 3, 3 is in the shaded area, we can still use it for the second line. So 3 is going to be the y, and the other 3 is going to be for the x. So it's a -1/3 times 3 plus 2, which is a -1. In this case, in order to make 3 and -1 work, well, we're going to need a greater than. So, oh, sorry, it's not a negative one, it's a positive one. So we're still going to need a greater than. There you go. That's our system of inequalities. That's example 1. Moving on, example 2. Same process. Let's start with this line. And by the way, this is a curly braces. At the top and bottom, you could choose to write them like symmetrically, but it's just a curve with the little tip that's pointing out. Let's start with that line. Y-intercept is a -3. Left side is just a y. The slope is down 3 over 1, so it's a -3x. The second line, this one, the slope is the y-intercept is a 2. The slope is a down 1 over 2, so it's a -1/2 x plus 2. Left side is a y. Now, 0, 0 this time is actually in the shaded area, so we can just use 0, 0 to check. 0 for y and 0 for x. We will get a 0 on the left side, a -3 on the right side. In order to make this true, 0 is greater than -3, but at the same time it's a solid line, so it's supposed to be greater than or equal to. Now for the other one, same thing, 0 for y and 0 for x. We have 0 on the left side, a 2 on the right side. In order to make it work, it's supposed to be less than, but since it's a solid line, it would be less than or equal to. And that is our inequality for example 2. Moving on, example 3. Now for example 3, we also have 2 lines. Let's start with the tilted line first. It's going through 1. And the slope is up 3 over 1, so it's going to be a positive 3x plus 1. Left side is a y. As for the second line, well, that one is just going to be a horizontal line crossing the y-axis at -2. So it's a y on the left side and a -2 on the right side. Now let's choose points to check. We can just pick -2, -3, for example. Y is a -3. The right side is a -2 times 3, which is a -6, plus 1 is a -5. In order to make that work, we need greater than. It's a dotted line or dashed line, so it's just going to be greater than, no equal symbol. And then we can do the same thing with the second one. Plug in the -3 for y. We've got a -3 on the left side and -2 on the right side. And -3 is actually less than -2, but it's a solid line, so it's going to be less than or equal to. That is example 3. Moving on, example 4. Let's start with this line right here. Y on the left side is going through -3. The slope is up 4 over 3. So it's 4/3 x. And then the second one, we have a y on the left side. As for the right side, well, the y-intercept is at 3 and is down 2 over 3. So it's -2/3 x plus 3. For the first line, well, we can actually use, let's say, 2 -2 to check. Well, actually, since the fractions are all over 3, let's actually use 3, 0. It's actually easier. 3, 0. Y is 0. The right side, 3 times 4/3 is a 4, minus 3 is a 1. In order to make it work, it's less than dotted line, so there's no equal sign. I'm going to do the same thing with the other one. 0 for y. 3 to the right side is a -2/3 times 3, which is a -2, plus 3 is a positive 1. So it's also a less than symbol. That's example 4. Moving on, example 5. The two lines have the exact same slope, just different y-intercept. The slope is 1, so the first line is, well, let's say this one is going to be a y on the left side, the right side is a x minus 1. And then for the other line, y on the left side, right side is x plus 3. So for both lines, we can actually use 0, 0 to check. First line, we're going to get a 0 on the left side, a -1 on the right side. So it's going to be a greater than or equal to. It's a solid line, so it has the equal symbol. The second one, 0 on the left side, 3 on the right side. So it has to be a less than. So it's y is less than x plus 3. There you go. That's example 5. Example 6. Let's start with this line. That line has a y-intercept at 9. And the slope is a down, let's see. the slope is a down 3/4, so it's a negative 3/4 x plus 9. And then the other one, y on the left side. The other one is this one. This one. Okay, y-intercept is at 7, and it's down 1/2, so it's negative 1/2 x plus 7. Let's pick a point to use to check. Well, we don't have too many points, but we can still use 0, 0. It's on the edge of the shaded area, but it's still kind of in the shaded area. So 0, 0. For the first one, we got a 0 on the left side, a 9 on the right side, so it's going to be less than or equal to. And the second one, 0 on the left side, a 7 on the right side, so it's also less than or equal to. But here's the issue. If we only have these two inequalities, you're also supposed to shade everything over here and everything below and everything over here because they're also below the lines. However, now you can see they're not shaded, which means we actually have more lines. We have one line here and another line over here. These lines are just the axis. The y-axis is going to be an x equals 0, and the x-axis is going to be a y equals 0. Because for the y-axis, it's crossing the x-axis, so it's x. The other one is a y. Okay, and we're basically having every single thing in the first quadrant. This is your first quadrant. Everything in the first quadrant is positive, so it has to be just greater than or equal to 0. That's what's special about example 6. Now you can pause here to try with example 7. Hopefully you have tried it. There you go. Here are the answers. The first one, well, this is referring to this line. And the second one is referring to the line that's crossing at 4, so this line. The third one is referring to this line. And then, of course, you still have one cutoff right here. This is your cutoff. That part is your cutoff. So we still have the x is greater or equal to 0 and y is greater than or equal to 0. That is everything in 3.8b lesson. Thank you.